In this video, we're going to go from quadratic expressions to quadratic equations. So first, here, hold on, First, let's talk about what is a quadratic equation, and hopefully you watched part one, which talked about quadratic expressions, and a quadratic expression simply an algebraic expression where the greatest exponent, the largest exponent, is a 2. So it could look like, say, x squared plus 5x minus 3, or say 2x squared minus 5, as long as the largest exponent is a 2. These are quadratic expressions, but a quadratic equation is simply a quadratic equation with an equal sign, equal to 0, ax squared plus bx plus c equals to 0, or anything that can be written in this form. For example, if I gave you x squared plus 5x equals to negative 12, this can be written in this form because we can add 12 to both sides and set it equal to get to 0, giving you x squared plus 5x plus 12 is 0. Okay, so we need to know what is a quadratic equation. We also need to know the zero product principle. And zero product principle says if we multiply two values together and we get 0, we know one of these values has to be 0. So either a is equal to 0 or b is equal to 0. So if I multiply two binomials together, say x plus 2 and x minus 3 together, and I get 0, I know that either x plus 2 has to give me 0 or x minus 3 has to give me 0. One of these expressions has to be 0 in order for our product to be 0. And that is the zero product principle. Okay, so let's use that information and talk about solving quadratic equations. So there's two ways to solve quadratic equations. One is by factoring, and the other is by using the quadratic formula. So first, when you are solving quadratic equations by factoring, it's that straightforward. The first thing you want to do, let me erase this, hold on just a second. When you're solving a quadratic equation by factoring, the first thing you want to do is you want to make sure that your equation, so you want to set your equation equal to 0. So for example, if your equation was x squared plus 5x equals to negative 6. This is a quadratic equation. The largest exponent is a 2, and it has an equal sign, so it's no longer an expression, it's an equation. The first thing we want to do is set this equation equal to 0. So I need to add 6 to both sides. And when I do that, I get x squared plus 5x plus 6 equals to 0. And notice I'm not combining any of these because these are not like terms. So after you set your equation equal to 0, the next step is to factor the quadratic expression. So here, this is one of the more simpler types of quadratic equations, so or expressions, because your leading coefficient is 1. If you recall from the previous video, if your leading coefficient is 1, you can multiply, find your binomials pretty easily by finding two numbers that multiply to give you your x squared, which is x and x. And then you look for two numbers that multiply to give you your 6. And when you add two factors of 6, that when you add them you get 5. And those are going to be plus 3 and 2. Check that real quick. X times x is x squared. That's going to give me a 2x. And then a 3x, and then a 6, and 2x and 3x is 5x. So we know we factored this correctly. So obviously you have to have a good grasp on factoring before you can get to this part for solving a quadratic equation. So when you solve a quadratic equation, the first step is to set it equal to 0, which we did here. Your second step is to factor it. Your third step is to set each new equation, or each linear equations. These are linear equations because they're of the form ax plus b equals to 0, where your exponent is 1. So set each linear equation or each new equation equal to 0. Now let's talk about, actually let me rephrase that. we're going to, I got ahead of myself. So here we factored it. So this is step 1. We set it equal to 0. Step 2, we factored it. And then step 3, we use the zero product principle. Which says that if you have two factors, and when you multiply them you get 0, then one or both of these must be 0. So we're going to use the zero product principle and set each factor equal to 0. So here, step 3, we're going to say either x plus 3 has to be 0, so either this has to be 0, or x plus 2 has to be equal to 0. So this has to be 0, because one of these must be 0 for our product to be 0. And then once you do that, our fourth step is to solve each new linear equation. And let's see, when we do that, I can subtract 3 from both sides here. This gives me x is a negative 3. Subtract 2 from both sides here, and x is a negative 2. So that was step 4. So our solutions are that x could be negative 3 or negative 2. And you can go back and substitute, just like we did with linear equations when we were checking our work. You can substitute a negative 3 in for x here and for x here, and hopefully it will give you a negative 6, and substitute in a negative 2 as for x here and x here, and that should also give you 6. So you can always check your work. Okay, so that's solving quadratic equation by factoring. You can also solve that same quadratic equation by using the quadratic formula. So let's remind ourselves, by factoring, we had x squared plus 5x equals negative 6. The first step was to set it equal to 0, so x squared plus 5x plus 6 equals to 0. Our second step was to factor it, so we factored this and we got x plus 3, x plus 2 equal to 0. Our third step was to use the zero product property, which tells us, or the zero product principles, which tells us that one or both of these must equal to 0 if their product is 0. So we set x plus 3 equal to 0, or, whoops, or x plus 2 equal to 0. And then the last step is to solve each of these new equations. So x could be a negative 3, or x could be a negative 2. So the solutions are x or negative 3 or negative 2. Now, the quadratic formula tells you if you have a quadratic equation of the form ax squared plus bx plus c equals to 0, so you can see that your quadratic equation needs to be equal to 0, then you can use the quadratic formula to find your x values. So to find your x, you would take plus or minus, or sorry, your quadratic formula is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Now, this is not just some formula that was made up. You can actually derive this, but we need to know a little bit more about quadratic formulas and solving them using something called completing the square, which we won't be covering here, but if you would like some information on that, just let me know. Okay, so let's talk about this formula real quick. Notice I said opposite of b here instead of saying negative b, and the reason that I said that is, for example, let's say if your problem was x squared minus 5x minus 7, then this is a negative 5, so the opposite of that would be a positive 5, or a negative 5 would be a positive 5. So that's why I like to use the term opposite instead of negative. So let's see there. So it's the opposite of b, plus or minus, and the reason we need a plus or a minus is because we're looking at two possible solutions. the square root, and the square root of a value, like the square root of 16, could be 4 or it could be negative 4, because 4 times 4 is 16 and negative 4 times negative 4 is also 16. So we need to look at both the positive and the negative options. B squared, remember whatever B is we're squaring it, minus 4 times A times C, and all of this is over 2A. So let's look at the same problem. X squared plus 5x equals negative 6, and the same thing, the first step you want to do is set it equal to 0. So here I'm going to start there with x squared plus 5x plus 6 equals to 0. In this problem, A is 1 because your leading coefficient of your squared term is 1. B is 5 because that's your coefficient of your linear term, and your constant term is 6. So once you know this, you're simply substituting it into the formula. The opposite of B, so this B is a 5, so the opposite of B is a negative 5, plus or minus the square root, B squared, so that's going to be 5 squared, I'll put that in parentheses, minus 4 times A, which is 1, times C, which is 6. This is all over 2 times A. So when we clean this up, we get negative 5 plus or minus the square root, that's going to be 25. Minus 4 times 1 times 6, that's going to be minus 24 over 2. Keep going, we get negative 5 plus or minus the square root of 1 over 2. Let's see. Running out of room here, so come back up here. This is going to give me negative 5 plus or minus 1 over 2, because the square root of 1 is 1, which then I've got two choices here. I can make this negative 5 plus 1 over 2, which is going to be a negative 4 over 2, or a negative 2. The other option is I could do a negative 5 minus 1 over 2, which is going to be a negative 6 over 2, or a negative 3. And so you can see negative 2 and negative 3 are the same solutions that we got up here. So x is negative 3 or negative 2. So you can do this using the quadratic formula. You can solve this quadratic equations by using the quadratic formula or by factoring. Alright, so for these examples, just quickly, so for problem number 1, notice this problem is already factored. So at this point, you've already gone through step 1, which is to set it equal to 0. Step 2 is to factor it. Step 3 is to set each factor equal to 0. So use the zero product property or principle, which says if you have two factors and you multiply them together to get 0, one or both of these must equal to 0. So I can add 5 to both sides. I get x could be 5, or add 2 to both sides. X could be 2. So here my solutions are 2 or 5. So that's pretty straightforward if your quadratic equation is already factored. And we know this is a quadratic equation because if we simplified it, x times x is x squared. Alright, in this second problem, actually I'm going to hold off on that one. I'm going to go here. I'm going to let you do this one for practice. Here, when we have x squared minus 6x equals to 16, remember your first step in whether you use factoring or whether you use the quadratic equation is to set this equal to 0. So I'm going to subtract 16 from both sides, giving me 0. And then I'm going to solve this both ways. I'm going to first factor. And when I factor, again, I'm looking for two numbers that when I multiply give me negative 16. When I add, they give me a negative 6, so that's going to give me two numbers are going to be a negative 8 and a positive 2. And when I do this, so the first step was to set it equal to 0. The second step was to factor it. The third step is to use that zero product principle, which says if you have two binomials, or excuse me, two factors that when you multiply them they give you 0, one or both of those must be equal to 0. So either x minus 8 equals to 0 or x plus 2 equals to 0. And then the last step is to solve these new equations here I could add 8, and I can get 8, or subtract 2, in which case I get x is a negative 2. You can take those and check them, substitute them back into the equation, and when you substitute a negative 2 here and a negative 2 here, and then subtract 16, you should get 0. Additionally, when you substitute an 8 here and an 8 here, and then subtract 16, you should also get 0. Alright, so when we solved this equation by factoring, we got x is negative 2 or 8. Now let's solve that same equation using the quadratic formula. Let me just clear this page just a little bit. So the quadratic formula again is the quadratic formula says if your equation is of the form ax squared plus bx plus c equals to 0, which ours is, it's x squared minus x squared minus 16x. Whoops. Sorry about that. X squared minus 6x minus 16 equals to 0. Then you can use the formula to find your values. X is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Alright, so let's go in here and let's just remind ourselves a in this problem is 1 because my leading coefficient's 1. B is negative 6. And c, your constant value is negative 16. Alright, so x is equal to the opposite of b. b is a negative 6, so it's going to be a positive 6. Plus or minus the square root, b squared, so that's going to be a negative 6 squared. I'm going to put that in parentheses so I can remember that I'm squaring the negative. Minus 4 times a times negative 16. And all of that is over 2 times a, which is 1. Okay, so clean this up a little bit. I get 6 plus or minus the square root of negative 6 squared is 36. 4 times 16 is 64. 64. And all of this is over 2. Keep going. You can see where this is going. Plus or minus the square root of 100 over 2. And now let me come over here. And so that's going to be 6 plus 10 over 2, or 6 minus 10 over 2. Because the square root of 100 is 10, and we have to look at both the plus option and the minus option. 6 plus 10 is 16. 16 divided by 2 is 8. 6 minus 10 is a negative 4. Negative 4 divided by 2 is a negative 2. So you can see we get the same solutions as factoring. So if you're comfortable with factoring and you know, it may seem that that's the easiest, not every problem is factorable, in which case you will have to use the quadratic formula. But as you can see, if they are factorable, then it's possible to factor or to use the quadratic formula to solve. Alright, please let me know if you have any questions.